Hi all, welcome to my channel Chadavari Talks. I would like to thank you all for subscribing my channel and sharing your comments. Happy New Year to all. So today's video would be about joins in SQL. We will try to see what are the different joins that are available in SQL. If you see the slide over here, it listed all the joins that are available in SQL like inner join, outer join. Again in outer join we have three categories: left outer, right outer, full outer join, self join and cross join. We will try to see everything in detail for what set of requirements, which type of join can be used, and how do we use these joins in our data engineering world. Let's see inner join. If you see inner join is normally used when you have two or more tables and if you wanted to get a matching records from the tables that are participating in the join condition. So if you see the Venn diagram over here, I have taken only two tables, table A and table B. And if you wanted to get the matching records of both the table, for those kind of requirements, we would be using inner join. I have just taken some sample tables to explain in detail about this inner join. One is employee table, another is department table. If you see in the employee table, we would have three columns: employee ID, employee name and department ID. Similarly, the second table is the department table. We have department ID and department name. Now I'm trying to join these two tables. For each and every employee, I would like to get the department associated with this employee. If you see the output, I have presented the output also. We have employee ID, employee name and the department name. So now in the employee table, we don't have a department name, and in the department table, we don't have an employee information. If you have a requirement to get a combined information from two or more tables, for those kind of requirements, you would be going an inner join. In inner join, only the matching records information will be presented as an output to you. So if you see the employee table, we have four records, out of which for employee 2, employee name Sita, we don't have a department associated. This scenario can occur in your real life also. You may join a company or an organization which they will not directly assign a department to you. They will be placing you on bench or a common pool. That kind of scenarios must occur. So similarly in this requirement also, we don't have a department for employee 2. Now if we wanted to know what are the departments that are associated for each and every employee, we are going with an inner join. You can see the query which I presented also. So I am selecting the employee ID, employee name and department name, and I am joining the employee table using a join keyword with the department table, and this is the join criteria. In this particular slide, I have used department ID as a common column between both the tables. In any of your requirements, when you wanted to create a join, you should have a common column to create a join between the tables. Normally these column names will be different or it can be same. As it is like a learning platform for you, I have taken the names as same in both the tables. It gives you an easy way of understanding. So the department ID in the employee table is joining with the department ID of the department table, and we are trying to bring the department name of that particular employee. If you see the output result, I have taken employee ID, I have taken employee name, and I have also got the department name. For employee Sita, the department is nothing, so it is not able to get the related match from the department table. For employee 1, we have department 1, so we got IT as a department. For employee 3, we have department as D2. The corresponding match in department table is HR. We got HR as a department name for employee 3. For employee 4, the department ID is D3. The corresponding match in the department table is finance, and we got that as a department for employee 4. So the Venn diagram over here represents you a clear understanding of the matching records which are represented in color blue. I hope the inner join is clear for you. Let's go with the next join. Left outer join. So what is left outer join? So as I mentioned previously, when you have to create a join, it is mandatory that you need to have two or more tables. So if you have taken two tables like how I'm showing you in the slide, if you have taken employee table and department table, irrespective of an employee has a department or not. If you want all the information of an employee, normally if you want to see how many employees are present in an organization or a company, or if you wanted to give some salary hikes kind of a requirement, you will be using this kind of a left join scenario. So I have an employee table, I have a department table, and I'm trying to create a left join, and I'm trying to bring all the employee related information irrespective of the matching department associated with that employee. If you see the result here, I got all the employees 1, 2, 3 and 4. For employee 2, there is no related match in the department table. That's what the output is written as blank. So how we represent this in a Venn diagram, I have shown it over here. So we have table A, which is an employee table. We have table B, which is like a department table. If there is a match, we are retrieving that match from the department table. When there is no match, but still we are retrieving the employee record, but the related information from the department table will be blank. So how to create a query for this left join? So select from employee table, left join, department table on the department ID, the same fundamental rule what we have followed in inner join. The matching columns of the employee table and the department table has to be included in the join condition. So we have joined on the department table from the employee table and department ID from the department table by giving an aliases, and we have presented all the required information in the select clause which we wanted in the output. I hope left outer join clears to you in detail. Let's go with right outer join. So what is right outer join? Similarly, what we have seen in inner join and in left outer join, we would be having 2 or more tables in right outer join also. But here the fundamental rule differs from left outer join. If you want all the information from the right table, irrespective of the matching records from the left table, for those kind of a scenarios, you would be using right outer join. Normally in your data engineering world or the project which you work, you always use left outer join, and you will try to replace the table names, putting everything, the information what you wanted on the left side of the join criteria. There are some requirements, especially in the interview questions or in your certification related kind of exams. They may ask you what is right outer join. For those kind of situations, you will be getting a better understanding of this particular slide. So I have taken an employee table and a department table, and I am trying to get all the records of the department table irrespective of the matching records in the employee table. So if you see here, we have employee ID, we have employee name and department name. So we have 4 departments here. We got all the 4 departments. For department 4, there is no related employee. So there can be a scenario. When you start a company or an organization, you would be identifying the departments, but the department may not be having any employees. For those kind of requirements, you can use this right outer join, the scenario which I was showing you in the slide. So how we represent this in a Venn diagram, the same fundamental rule what we have followed in left outer join, the same applies here also. The left side of the table, which is your department table, you will be trying to retrieve all the information. So that's the reason table B is represented in blue color, and table A, the matching records information is retrieved, and the records that are not having any matching record is not presented. So how do you create a right outer join? So you have a select clause from the employee table here on the left side and department table on the right side, and we have used a right join clause. And what are the columns that are participating on this join? The department ID of the department table with the department ID of the employee table, and we are trying to retrieve all the required information in our select clause. I hope right join is clear to you. Let's go ahead. Full outer join. So what is full outer join? So we have seen inner join, we have seen left outer join, we have seen right outer join. The combination of all 3 joins in a single join is nothing but your full outer join. There might be a requirement you want a matching records, non-matching records of both the tables, either from the left table or a right table. For those kind of scenarios, you would be using a full outer join. So if you see the slide over here, I have taken the 2 tables, the employee table and the department table, and I am trying to retrieve the matching records. the non-matching records of the employee table and the non-matching records of the department table also. So the total output is having 5 records, which is expected to have all the 3 matching conditions, which is your inner join, left outer join, right outer join. If you see, the employee 1 is having a related department IT and it got in the output. Employee 2, Sita, is not having a related match in the department table, but still it is presented because we are using a full outer join. Similarly, employee 3 is having department D2, which is HR. It is also presented in the output. Employee 4, which is having department D3, which is department finance, it's also presented. Now we are done with employee table. The next is department table. Now in the department table we have D1, D2, D3 are covered, but D4 is not having a related match in the employee table, but still it is retrieved in the output as we are going with a full outer join. The Venn diagram over here represents the full outer join condition. If you see, the green color represents the inner join, the blue color represents the left outer join, and the yellow color represents the right outer join. So how do you build a full outer join query? Same thing, you need to take the left table and the right table and you have to use a full join clause. And the columns that are participating in this condition, in this join condition, are your department IDs from the employee table and department IDs from the department table. You need to specify all the columns in the select clause, what all that you have wanted to present it in the output. So here we have taken employee ID from the employee table, employee name from the employee table, and department name from the department table. I hope full outer join is clear to you in detail. Let's go with self join. Normally self join is a join condition that we frequently used when the same table has to be participated in the join condition. So as I mentioned previously, you need to have 2 or more tables to have a join criteria. But here there are some requirements. Only a single table will be given to you and you need to create a join condition using the single table. So as a single table is participating in the join criteria, that is the reason we'll call it as a self join. If you see the employee table here, the output or the data of the employee table is same in both the things. So one set of employee table I have taken as an employee level information. For the another set of employee table I have taken to represent the manager level information. Now for what set of requirements you will be using self join, we will be seeing. Normally when you are working on some projects kind of requirements, they will ask you to give information about an employee and its related manager. So normally a manager is also an employee in the company. You will not have a separate manager table to retrieve the manager level information. So using the same employee table, you need to get the employee level information and also manager level information. For those kind of requirements, you would be going with self join. So self join is almost all equal to your inner join, but the only thing is that like you will not have 2 tables, only a single table will be participating in the join criteria. So the output over here, if you see, I am planning to retrieve employee level information and also the manager level information for that particular employee. I have taken 8 records in my employee table and I have the related managers for all of them. If you see for employee 1 Ram, the manager is God. If you see for employee 2 Sita, the manager is Ram. For employee 3 Lakshman, the manager is again Ram. So for a single person Ram is 2 people are reporting. One is Sita and another is Lakshman. So similarly, if you see Jesus record, we have manager as God. And for John, the manager is Jesus. Similarly for Ali, the manager is God. And for Syed, the manager is Ali. So if you see this hierarchy over here, under God we have 3 employees, Ram, Jesus, Ali. Under Ram we have 2 employees reporting Sita and Lakshman. Under Jesus we have 1 employee reporting John. Under Ali we have 1 employee reporting Syed. That is the reason we have got all the information in the output as shown in the slide. So how do you create a query to retrieve this information? You can see I have taken one instance of the employee table for employee level information, another instance of the same employee table to represent the manager level information. The Venn diagram gives you a clear understanding of the self join. I have taken employee table on the left side and manager level information of the same employee table on the right side. Here only the matching information will be retrieved because I'm using a inner join kind of a condition. Even though the tables are of same thing, I want only the employees who are having its manager. If there is no matching record, you will not be getting the manager. So for God, there is no matching information here. That's what it was blank. So wherever it is having, so normally this record should not be retrieved because God is not having any information in the table. So now we don't have a manager here, so this record will not be shown. I just represented here only for your understanding, but output will not have 8 record God because there is no related manager in the manager ID column. So only you will be getting 7 records as an output. Just to understand you, I have represented 8 record which will not be blank. When you go with the left join, you will be getting the 8th record or a right join also. So hope self join is clear to you, especially when you're attending interview level kind of a requirements or for your scenarios. This self join question or a query will be asked. So you can use the same query which I shown you in the slide and you can present it. Let's go with cross join. What is cross join? So cross join will be used when there is no columns participating in the join condition. So you can have 2 tables. As I mentioned, whenever you're creating a join kind of query, you need to have 2 or more tables. I have taken customer table, I have taken products table here. For the customer table, we have 3 records, and for the products table, we have 3 records. Each and every record of the customer table will be creating a mapping with all the records in the product table. If you see the slide, I have represented customer 1 is having a relation with A, B and C. It is trying to create 3 records for one instance of the first record in customer table. Similarly, customer 2 is having 3 records relationship with products table A, B and C. Similarly, with customer 3, it's having 3 relationship with products table A, B and C. So the output will totally having 9 records. So how do you represent a cross join? A cross join is represented by M cross N, M multiplied by N. So what is this M? What is this N? Number of records in the first table multiplied by number of records in the second table will be your output in cross join. So if you see the number of records in the first table is 3 records and number of records in the second table is 3 records, 3 cross 3 is 9 records in your output. But never go for cross join. It is very dangerous. It is only for your learning thing. In production, if you go with the cross join, it could crash your servers or your database because production systems would have millions and trillions of records. It would be very dangerous to go when you're going with a cross join. Even for your testing kind of a requirement also, never go for any cross join. If you wanted to test, take a sample table, create with 1 or 2 records and you can test it. Again, cross join will be created automatically when there are no columns specified in the join condition. It is like a simple query creating select columns from table A, table B. It will result to a cross join kind of a requirement. I did not given you the query here because by any chance, if you test it on a production systems or your servers where you're practicing it, it could create a problem. That is the reason I did not specify the cross join query. I hope join conditions are very clear to you. I hope this understanding gives you a clear understanding of the joins in SQL. Thank you. Let's see in next video. Once again, Happy New Year. Thank you all.